So, a system of equations is a group of two, no, I'm going to change that, a group of at least two equations which may or may not share a solution. Now, remember, a linear equation is should be an equation, not an equation which graphs a straight line and has a constant slope. So, if a system of equations is a group of at least two equations that may or may not share a solution, lovely. And a linear equation is an equation which graphs a straight line and has a constant slope. What then is a linear system? At least two linear equations which may or may not share a solution. Now, whoops. So, how do I find that solution? So let me give you an example. Y equals 3x plus 2. What would you say is the solution to this? Because as you can see, this has an equal sign, therefore it has a solution, right? So, how would you go about telling me a solution to that red equation? I'll make it easier because we're at the beginning of a unit. 2x plus 3 equals 5. How would you tell me the solution to that? Wow. Nobody can solve that. I'm just going to wait a moment while you have a look at that blue equation and really give it some thought before you commit to saying that none of you can solve it. You isolate x. So the final answer is going to be x equals what? 1. So to solve that, you need to tell me what x equals, because x is the unknown, correct? So how would you solve that? This is not a trick question. In the blue one, you had to tell me what x equaled. What do you need to tell me in the red one? What x and y equal. And x and y will give me coordinates, won't they? Coordinates. That's too many i's in there. Right? So, what do you think it means to solve a linear system? Because in a linear system, I have two equations. I have y equals 3x plus 2, and I have y equals 2/5 x minus 7. what do you think it would mean to solve that? What do I need to do to solve the red one? I need to find what? An x and a y. What do I need to solve the green one? I need to find an x and a y. Now, if it's a system and they're grouped together, then what do we know about that x and that x? They must be the same. And that y must be the same. Because if the x and y is on this line, and it's on this line, it is an x and a y that works in both. Therefore, it is the solution. Everybody good? Good. There's 3 ways to do this. Graphing, elimination, and substitution. Graphing is the worst. Why? As you well know, when you are graphing, that line goes through infinity numbers, doesn't it? And that line may not hit the other line at a nice perfect point, which would mean we cannot get an exact solution. But I start with graphing because we just finished a unit on graphing. So, to graph, find where the lines cross. So, there's my one line, there's my other line. They cross right there, right? That point right there has an x and a y, right? That point right there, x and y, is on the blue line, and it's on the red line. So that makes it the solution to whatever that system is, okay? So the first way you're going to learn to solve these is just by graphing. So, easiest way to graph from looking at something is to put it into slope-intercept form, correct? Remembering that m represents slope, b represents the y-intercept. Then, you graph them by going to the y-intercept of both lines and counting slope of both lines. Where they cross is the answer. Everybody cool? You've all seen it before, while the grade 8 and 9s won't have. So let's do it. First thing we need to do is graph these. Now you will notice on this graph paper, I have not given you an axis, have I? That is because we do not know where the y-intercept is going to be yet, correct? If the y-intercept is -5 and the slope is negative, then we are going to want to be up here, aren't we? So we can go to -5 and do a downward rise, right? So that's why I haven't given you the axes yet. First thing you should do is see what they're going to look like. So I'm going to graph these lines, that one red, that one blue. You guys should all do that as well. What do I do with the red one to put it into slope-intercept form, which is what you just wrote a test on, so every single one of you should be racing to give me this right answer, so I know that you're intelligent young people. Go. What's moving? Can I graph that now? Mm-hmm. What do I got to do with the blue one? Move the x. Then what? Divide by 2. So, Positive 4, positive 1. They're not big. So we can go ahead and we can put the axis anywhere we want to. There's mine. So I graph the red line by going to 1, 2, 3, 4. And what's my slope? -1. So down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. And that line will go on forever, yes? So I'm going to go ahead and sketch it in. Now, the blue line. Where do I go? Up to 1, and it's 1/2. So up 1, right 2. Oh, there it is. And that, I'm going to use purple because red plus blue equals purple. What's that point right there? What is it? 2, 2. Now, as always, none of you are going to do this, but of course you should. Once you get an answer, it takes about 3 seconds to know that it's the right answer, so you don't hand it in and lose marks. That 2 is an X, that 2 is a Y. Is 2 plus 2 4? Yeah. 2 times 2 is 4, right? Is -2 plus 4 2? Yes, so are we correct? Yes, that's the answer. That's how easy it is. Everybody cool? Awesome. Do the next one. What's moving? My guess is 2, -3. Am I right? Am I right? Am I right? Yes, I am. And finally, this one. Now listen to me. This one is weird. A great many of you probably haven't seen it before. But I'm doing this to show you something. Okay? How many of you, and I'm guessing not many of you, have seen that notation before? I'm betting only Takanari has seen that notation before. And that is because he's from another country where they actually teach math. Not like here. So nobody has seen that, right? Okay. Those lines, which you're going to see a lot of in the next couple of years, they mean the absolute value of something. Absolute value is a magnitude. There is no direction. Okay? So on a number line, this is just a quick little extra thing, and trust me, I'm going somewhere with this. There's 0, yes? If I take 3 steps to the right, where am I? 1, 2, 3. I'm at positive 3, correct? If I go back to 0 and I take the same amount of steps to the left, where am I? Negative 3. Everybody cool? Now, because one is positive and one is negative, those are vectors, aren't they? Because they have a direction. Absolute value is a magnitude. This is 3, and this is 3. So the absolute value of any number is its distance from 0. So the absolute value of negative 3 equals 3. The absolute value of positive 3 equals 3. Does everybody understand? Everybody cool? Okay, so now let's go over here and see what we can do with this. This, and I'll do this all in red, we're going to use a table of values because, again, you haven't seen it before. X, Y. So give me 3 x's, some negative, some positive. Negative 2, 0, and 2. How's that? Okay. If x is negative 2, that means that's going in there, right? So what is the absolute value? It'll catch up. I'll have a bite of pupusa while we wait. I'll have another bite of pupusa while we wait. Whoa! If x is negative 2, how far is it from 0? 2. So y is 2. Agreed? When x is 0, how far is that from 0? 0. When x is positive 2, how far is that from 0? So we're back to 2, correct? Okay. Then the blue one, of course, is already nicely set up for us, right? So let's put in our graph. All right, so the red guy, when x is negative 2, y is 2. 0, 0, 2. Now you can see I go over 2, up 2, so I'm going to continue to go over 2, up 2, over 2, up 2 on both of them, right? Making this sassy V graph. Everybody cool? Now, you're smart young people. Since this graph makes a V and the other graph makes a straight line, how many times is it going to hit? Twice. So how many solutions will this system have? 2. So let's graph this bad boy. Up, 1, 2, 3. Down, up 1, right 2. Up 1, right 2, up 1, right 2, up 1, right 2. There's 1 solution. And down 1, left 2. There is the other solution. And they are 1, 2, 3, 4, 5, 6, and 6, and negative 2 and 2. Does everybody understand? Now, where you're going to take this in the next year is your graphs won't be straight lines. They'll be curves, and the curves will hit each other. And every time the curves hit, that's a solution. Everybody with me? So let me give you an example of what I mean, just because you've all seen this now and know what it looks like. If we graphed the following, if we graphed a sideways parabola like that, and then we graphed a vertical parabola like that, how many solutions does that system have? 4. Everybody understand? That's where you're going with this. Everybody cool? Okay. Sweet. That makes the guy happy. All right. I'm done then. So what you have to do now, between now and 12:05 is too long. I'm going to give you 20 minutes to finish page 232. I think that was the assignment, was it not? Yep. I'm going to give you 20 minutes for that. Then we're going to mark, whatever, no, the whole assignment of page 232. It's page 232, 233, 234, 235. But since everybody except 2 of you finished the test way before the end of the block, you all should have gotten a very good head start on this. Most of you didn't, because as soon as you finish a test, you play on your phones. But that's your fault, not mine. What? For the next 20 minutes, you're working on this. If that is done, we will be marking it in 20 minutes. If that is done, you will start working on page 239. Okay? Everybody good? Good. I expect you to be comfortable with page 239, and we will have marked 232, and we will probably have gone over your test by 12:05. The last block will be spent doing the next 2 versions of solving. Go. Now, I am here for assistance, of course, whatever you choose to work on. If you have already finished 232, you should be very comfortable with 239. You shouldn't need any help with it because it's just graphing lines. It's what you just wrote your test on. You just graph 2 lines per question. Okay? Okay. Let's see if our good friend the internet is still working. That's weird. The internet is working on this computer, but not on this computer. Yeah.